State how a vector quantities differ from a scalar. So what is the difference between a scalar and a vector? That the vector quantities have direction. So if a quantity is a vector, it has direction. The scalar is having a magnitude and unit, but it does not have any direction. Then circle the vector quantities in the list. So first we check acceleration. It is a vector quantity. Energy is a scalar. It has magnitude unit, but it does not have any direction. Mass also it's having a magnitude and unit, but no direction. Momentum is a vector quantity. It has magnitude, unit, as well as direction. Temperature, magnitude and unit only. Time, magnitude, unit. Speed, magnitude, unit. And velocity is also having magnitude, unit, and direction. So these are the three vector quantities. A microphone is in a recording studio, has a mass of 0.55 and a weight W. So what is the weight of this microphone? So the formula to calculate the weight from the mass, weight is equals to mass multiplied by gravity. So W equals M into G. So mass is 0.55, and what about the value for gravity? It is actual value is 9.81, but because we are taking all as 10, so we'll multiply the rounded off value is 10, so we multiply it by 10, so it will become 5.5 Newton. In part C2, the microphone is suspended from a ceiling by a cord, as you can see here. A small ring is there, so there's a small ring. Shows the microphone pulled one side and kept stationary by a horizontal thread. So the microphone, as you can see, the horizontal thread is there, there's a ring, and the microphone is kept stationary or at rest. The tension T of a horizontal thread is 8.1. So we know the weight also, and we know the tension. So this tension, the horizontal tension is 8.1. So this one, the force which is acting equals to 8.1 Newton, and the weight of the microphone which is acting down is equals to 5.5 Newton. So the question is, determine graphically the magnitude and the direction of a relative to the vertical of the resultant of W and T, and use a scale. So scale diagram, 1 centimeter is equals to 1 Newton or greater. Then we have to determine the magnitude of the resultant and direction of resultant relative to the vertical. So how we can use it, because we need this figure to work out. So first, weight is 5.5 is there, and the tension is 8.1. So the weight which is acting down, that is 5.5 Newton, and the tension is 8.1 Newton. And we have the scale, like example, they said 1 centimeter is 0.1. So the scale is there given, 1 centimeter is equals to 1 Newton or greater. So 1 centimeter equals to 1 Newton. We'll use the parallelogram method. So in a parallelogram method, if 1 centimeter is equals to 1 Newton, so 5.5 Newtons will be equal to 5.5 centimeter, and 8.1 Newton is equals to 8.1 centimeter. And what is the angle between the two vectors? That angle is 90 degrees because they are perpendicular to each other. So how we work out the resultant? So first we draw a line, a parallelogram method. We place a point and we start both vectors from the same point. So we start both vectors from the same point. So we draw the first vector, which is 5.5. Then we draw the second vector. The second vector is 8.1 Newton. So the angle between them is 90. So 8.1 Newton means 8.1 centimeter. So we draw the second vector, 8.1 centimeter. And the angle is 90 between them. So 8.1 centimeter and 5.5 centimeter, two vectors. Now we complete a parallelogram. So when we draw 8.1 centimeter and 5. So we'll draw a vector here, like complete a parallelogram. And what about the resultant of this? So this will be 5.5 and this is 8.1. So the resultant is a diagonal. So we draw the diagonal from starting of the two vectors till the end of the other side. So this will be the resultant. And how we'll know what is the value of the resultant? To know the value of the resultant, we'll measure this length. So when we measure this length, example, this length is coming out, say 9.7 centimeters. So if it is 9.7 centimeter, so what is the resultant? The resultant will be equal to 9.7 newtons. And what about the angle from vertical? So this is a vertical line. So we need this. We will use a protractor and measure this angle. So we'll place a protractor and measure this angle. Say this angle is about 56. So the angle is 56 to the vertical. We work out using a scale diagram. Scale is already given. So magnitude is about like 9.7 is there. And the resultant direction of the resultant to the vertical means the angle is about 56. The second part, state and explain how the magnitude and the direction of the resultant in C2 compare when the force on the ring due to the tension in the cord. So what we want to determine, state and explain how the magnitude and direction of a resultant in C2 compare with a force on the ring due to tension in the cord. Like example, when we work out the resultant of horizontal thread and the weight, the resultant, this was the direction of the resultant. Like the weight was acting downward and there was a tension. So weight was acting downward and there was a tension in the thread which was about 8.1. So when we calculate the resultant, so this was our resultant. And now we want to compare this resultant with the tension in the cord. So when we compare the resultant with the tension in the cord, so this resultant which we calculated here, resultant of horizontal thread and the weight will be equal to the tension in the cord. How it will be equal to tension in the cord? Because the ring is stable. Ring is at equilibrium. So if ring is at equilibrium, if I say this ring is stationary or ring is at rest, so there is no resultant force. So if there is a force which we calculated, like example, we calculated the resultant of horizontal thread and the weight, that resultant was 9.7 Newton. So how much the force of the cord should be there? So the force of the cord should also be 9.7 because this ring is stationary or it is at rest. So answer for the last part, how we can compare this tension in the cord with the resultant of the horizontal thread and the weight. So they will be equal to each other. And why they're equal to each other? Because the ring is stationary or ring is not moving. So ring is at rest, so no resultant force on the ring. And as a result, if there is no resultant force on the ring, the tension in the cord balanced with resultant of weight and horizontal force. A student carry out experiment using a plastic beaker that contained 0.24 kilogram of a water at 17 degrees. The thermal capacity of a beaker is negligible. What is the meaning or a definition of a thermal capacity? Thermal capacity means energy required to change the temperature of given mass by 1 degree centigrade. It can be any mass, but a given mass. So basically, it is energy required to change temperature by 1 degree centigrade. In part B1, several ice cubes are at 0 degree centigrade. The ice cubes are dropped into a water and the internal energy of a water decreases. Give a simple molecular account to this decrease in internal energy. Like why the internal energy of the water decreases? Because what happened when we add ice cube, the water will lose energy and ice will gain energy. So the water particles will move slower. So as they will move slower, the kinetic energy will decrease. As a result, the kinetic energy decrease, so internal energy will also decrease, because internal energy is the sum of kinetic and potential. So water particles lose energy. As a result, when these water particles lose energy, what will happen? The particles will move slower. The kinetic energy of the particles will decrease. As a result, when the kinetic energy will decrease, the internal energy will also decrease. And why the internal energy decrease? Because the internal energy is a sum of kinetic and potential. The next part, the specific heat capacity of a water is 4200. Calculate the decrease in internal energy of a water as its temperature decreases from 17 to 0. So how much water was there? A cup contained 0.24. We need decrease in internal energy, or how much internal energy or energy change. So we have the formula which relate the specific heat capacity and energy. E equals Cm delta T, or C equals E divided by M delta T. C is a specific heat, which is 4200. A mass of water is given in the first part, 0.24, and the temperature change. Whenever you are putting a temperature change, it's not final minus initial, it is always greater minus smaller value. So here it is 17 originally, and then it turned to 0. So we'll write 17 minus 0, not 0 minus 17. Because temperature is a scalar quantity, so temperature change, the magnitude we need. That's why it is always the greater value minus smaller value. So E is equals to Cm delta T. When we supply, it will give us about 1.69 exponent 4, or 1.7 into 10 to the power 4 joules. As the temperature of a water decreases, some of ice melt. Why the ice melts? Because the energy is used to break the bonds. So as a result, what happens when the water particle loses energy, the ice gain energy, and the energy is used to break the intermolecular forces. So ice absorb energy which break the intermolecular forces, or we can also say forces between the molecules. Describe how to determine the specific latent heat of fusion of ice using this experiment, and state any other measurements which student need. So basically, what we did, we took a container, and that container was filled with water at 17 degrees centigrade, and we add ice cubes to this. So as a result, when we add ice cubes, the energy, the water will lose energy and ice will gain energy. To calculate the latent heat, the formula for the latent heat is equals to energy divided by mass. And what about the energy? The energy, we assume that this ice which is melting, it absorbs all the energy from the water. So energy absorbed by the ice is equals to energy lost by the water. So the energy E is equals to E is equals to energy lost by the water, which is gained by the ice. And what else we need to get the latent heat? We'll measure the mass of ice before and after to find the mass of melted ice. So we'll have the energy, we'll have the mass. So when we divide, we'll work out the latent heat or specific latent heat. In question 3, figure 3.1 shows a balloon inflated with air. The pressure of air at inner surface of a balloon keeps the rubber stretched. Explain in terms of momentum of the molecule why there is a pressure at the inner. So this is always a common question, like explaining the pressure exerted by the gas in terms of momentum. So gas molecules, first thing is gas molecules are moving randomly. And when they collide with the surface, it changes the momentum. How we can explain in terms of momentum? So gas molecules are moving randomly. As a result, when they're moving randomly, they collide with a, here we don't have a wall, we have a rubber. So they collide with the inner wall or inner surface of balloon. Changes momentum, exert force on unit area, create pressure. So this is always a common answer whenever a question is there related to explain how the gas molecule exert pressure in terms of momentum. So the wording always remain same. Then the volume of the air in the balloon is 630. So initial volume is given V1. The pressure 1 exponent 5 P1 is there. The balloon is tied to a heavy stone and dropped into a lake. The balloon is pulled down quickly and the temperature inside does not change. The volume of the air when the pressure is 1.4 exponent 5 Pascal. So we have P2. Whenever temperature does not change, because if there is a change in temperature, the volume is also affected by temperature. So we assume that the temperature does not change and we use a formula P1 V1 equals P2 V2. So P1 is the first pressure, which is 1 exponent 5. V1 is the first volume, 630. P2 is the second pressure, which is 1.4 into 10 to the power 5. And V2 is the second volume. So 1.4 exponent 5 is multiplied. Other side, it will be divided. So when we divide, it will give us 450 centimeter cube. The next part, a balloon and a stone stop moving when the stone hits the bottom of the lake. The temperature of air now begins to decrease. Why the volume of air in the balloon decreases as the temperature decreases? So what is the relation? Temperature and volume are directly proportional. So what will happen when the temperature decreases? The particles will move slower, and as a result, the particle moves slower. They will come closer to each other, or the pressure will also decrease. That's why the size of the balloon will decrease. Like if we increase the temperature, the particle move faster, the particle move away from each other. But as we decrease the temperature or the temperature decrease, the particles, the inside pressure is small as compared to outside pressure, so the volume will decrease. So you have to relate the volume and temperature. First thing, volume is directly proportional to temperature. That's first point. And then what happened? The decrease in temperature. The decrease in temperature decrease the kinetic energy and the speed. So the particles come closer to each other and they will exert small pressure or less pressure on the inner wall of the balloon. In question 4, a train is having a mass of 1.8 exponent 5 is at rest at a station at time t is equals to 0. Means in the beginning the train is stationary. The train begins to accelerate along a straight horizontal track and reaches a speed of 20 meters per second in 15 seconds. Then the train continues at this speed of 20 meters per second for 10 seconds. At 25, the driver applies the brake and the resistive force on the train causes it to decelerate from uniformly to a further 24 seconds. The figure 4.1 is incomplete. Complete a figure, a line to represent a motion from 15 to 25. So in the question from 15 to 25, because they mention the train continue at a speed of 20 meters per second for 10 seconds. So from 15 to 25, it is a constant speed. So how we represent a constant speed for a distance time graph? The distance time graph, the constant speed is represented by a straight line. So from 15 seconds to 25 seconds. So here each box is representing 1, 11, 12, 13, 14, and 15. So we have to draw a straight line because it shows that the speed is constant till 15 seconds. And then the first part, because they mentioned the train began to accelerate. So when acceleration means speed increases, so how we represent the increase in speed? So we'll draw a curve which gradient or the angle should increase, so which shows the object is accelerating. So here, the first part, it was accelerating. Second part, it is moving at a constant speed. And the third part, it is moving or it is decelerating until it reaches up or until it becomes or stop at this point, because distance is constant, so stop. Calculate the kinetic energy of a train between 15 to 25 seconds. So what was the speed from 15 to 25 seconds? So 15 to 25 seconds, it was moving at the speed of 20 meters per second. So the kinetic energy formula is half mv square, where m is the mass of the train, v is the speed. So ke, the kinetic energy, equals half mv square. So 0.5 multiplied by the mass of a train, which is 1.8 into 10 to the power 5, and the speed at which the train was moving is 20 square. So when we multiply all of them, it will give us 3.6 into 10 to the power 7 joules. This is the kinetic energy of the train. The next part, while the train is decelerating to rest, it work done against the resistive force and its kinetic energy decrease. Define work done. What is the work done? Work done is a product of force and distance. And it is a product of force and distance move along this direction of the force, or just a product of force and distance. You can also write a formula that work equal force into distance. Use figure 4.1, determine the distance moved by a train while it is decelerating. So how we can determine the distance moved while it is decelerating? This is a part where it is decelerating. So when it start to decelerate, it was at this mark. When it stop, this is a new mark. So how much each box on y-axis represent 20. So this one is 220, 40, 60, 80, 300, and this was 320. This will be 420, 40, 60, 80, 500, 520, 540, and 560. So when it started to decelerate, it covered 320 already, and when it stopped decelerating, it is at 560. So how much the distance covered while it is decelerating? So it is 560 minus 320. So when we subtract them, the total distance in this interval it will cover, that is 240. And the unit of a distance is given as a y-axis meter. So it will be 240 meters. So the distance moved equal to 240 meters. Then calculate the resulting force when it is decelerating. How to calculate a resulting force? So we have the work done. Work done is equals to force into distance. And here, because what happened when the train was decelerating, its kinetic energy is converting into heat or internal energy, or work is done. If we want to stop the train, which is having a, say, a kinetic energy of this was a kinetic energy which was 3.6 exponent 7. So if I say there is a train which is moving, and that train is having a kinetic energy of 3.7 into 10 power 7 joules. So if I want to stop this moving object, how much work I have to do? I have to do a same amount of work, but in opposite direction, so that we can stop. So we can also say the work done will be equal to kinetic energy if we want to stop. And if I say 3.7 exponent or 3.6 exponent 7 was there, the kinetic energy, so same amount of work is done to stop the train. So what we want to calculate a work done by the resistive force when the train is decelerating. So we have the formula work equals force into distance. So work is force multiplied by distance. How much is the work? That is 3.6 into 10 power 7. What is the force we are calculating, and how much distance it covered? We already calculated this part in the previous example, 240. So when 240 is multiplied, other side will be divided. So we'll know how much work, how much force is needed to stop this. So it will be a big number, 1.5 into 10 power 5 Newton. So this is the amount of the force needed to stop this train. So whenever a moving object is there and we want to make it stationary, the work done is always equals to the kinetic energy of the object. In question 5, explain in terms of behavior of light what is meant by principal focus of a thin converging lens. Principal focus means, like if we have a converging lens or a convex lens, so it is a point where all the light rays converge, like parallel light rays are there. The point where all the light rays converge, mix, combine, we call that point as a principal focus. So 2 mark definition is there. So your point, like it is a point where all the parallel light rays meet or converge. 1 mark is for mentioning the point. 1 mark is for mentioning the parallel light rays converge. So the point where all the parallel light rays converge or meet, we call that as principal focus. And what is meant by focal length? So if this is a convex lens and the point where all the parallel light rays converge, we call that as a principal focus. So we call that as a principal focus or focus. and the distance between the principal focus and the center of the lens is called a focal length. So what is meant by the term focal length? Focal length is the distance from center of the lens to the principal focus, or you can, center of the lens is also known as optical center. This center of the lens is also refers to optical center. So we can say the distance between the optical center or center of the lens and the principal focus is known as the focal length. Then a lens is used to produce a focused image of an object on a translucent screen. Translucent screen means the screen which allow the light to pass through. We call that as a translucent screen. And for a translucent screen, like if there's we can have two types of screen. We can have a translucent screen, or we might have an opaque screen. If it is an opaque screen, we cannot see the image here. That will be wrong. Then we should look from here, because when the light rays converge, there will be light on the screen and that will be reflected and enter our eyes, so we can see the image. But if it is a translucent screen, then we can see from the back of the screen as it allows the light to pass through. So in the question, consider ray of a light passing through from a tip of the object to the tip of image and find the position of the lens. So how we work out the position of a lens? This is a simple way. We take tip of object and we join with the tip of image. So when we join the tip of object with the image, the position where this line crosses the principal axis, that is the position of the lens. So what is the position of the lens? So this is the position of the lens. And mark the position of a lens by drawing a vertical line and label that with the letter L. So we label this with letter L. And on a figure, draw a ray that passes through one of the principal focus and determine the focal length. So how we can determine the focal length? So we already locate the position of a lens. Now the parallel light ray. So if the light ray is parallel, from where it will pass through focus. So we join till the tip. Again, we join the tip of image. So the point where this light ray intersect the principal axis, that we call that as a focus. So we have to determine this focal length. How we determine this focal length? So we'll measure a distance from the center of the lens, like optical center to this point, and we call that as focal length. And the scale is given dimension like 1, 2, like 1, 2, 3. This is 1, 2, 3, 4, and 5. 5 boxes equals to 1 centimeter. So you have to count number of the boxes from the lens to the point, focus point, and that will be equal to the focus. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 5 boxes equals to 1 centimeter. So 15, it will be equal to 3 centimeter according to this calculation. How we determine the position of the lens? Look, the simple way to locate the position of a lens is draw, for example, if in the question image and objects are given and you want to locate the position of the lens. So what you will do, you will draw a line from the tip of the object to the tip of image. And the point where this line intersects the principal axis, that is the position of the lens. So this is the position of the lens. And how you determine the focus? Now you take another light ray from parallel to the principal axis. It will pass through the focus and again reaches the tip of image. So the point where it cut or intersect, that will be the focus. So to locate the position of a lens, a simple way, Draw a line from tip of the object to the tip of image. Then object is printed. Object is a printed document that include a letter R on the side face. The top edge of a document correspond to the tip of O. On a figure shows how the printed document, figure 5.2 shows a printed document. On a figure 5.3, mark a tick on the box to indicate how the image is formed on translucent screen. And to someone who look at the screen at a point P, explain why the image appear like this. Look, the idea is that whenever the image is formed by a convex lens, it is always inverted. So if it is, if the image object was R, then what will be the position of the image? It will be inverted, so it will be inverted R. Because the image formed by a convex lens is all real image formed by a convex lens is always inverted. So if it was a B, then what will happen? It will appear as inverted image. So when we look at the image, what will be the correct answer? The first thing, A and B cannot be right. Why A and B cannot be right? Because A and B are not inverted. It should be inverted. So we are left with the other two. So what might be the image appear to be? So this will be the position of image. Like this is the appearance of the image. So image formed by a convex lens is always, real images formed by a convex lens are always inverted. So here in an answer, what you will write, you will mention it will be reversed and inverted. Or inverted also, if you mention, 1 mark is for the tick selecting, and the second mark that the real images formed by a convex lens are always inverted. So you can complete this statement. Only inverted, writing inverted will give you marks, but you can also explain the answer that real images which are formed by convex lens are inverted as well. Then question 6, I'll continue. I'll share another link and continue this discussion.